Swayam Prabha. Digital India. Educated India.
Is that clear, all of you? So is there any questions, any doubts? So I assume that things are okay with whatever I have said so far. So let's move on to the case studies.
Sir, during cyclone, only offshore transport is dominant.
Pardon?
During cyclone, sir.
Mostly it will be onshore during cyclone, cross shore. There may not be much of, again it depends on your angle of attack. So at certain locations it can be both. It can be longshore, there can be erosion because of the longshore current, there can be erosion because of the cross shore. But cross shore may be dominant also. So that is why it becomes more complicated. You have to do the assessment properly before you jump into what you want. So when you see for that type of an extreme event, when you look at the mitigation measure, you have to also have to look at the normal conditions. Normal situation, what happens. So that will give you whether the coast is dominated by the longshore currents or by the cross shore. And based on that, that will give you an idea about what kind of solution you can arrive at. Okay. The length of the coastline is approximately about 7,500 kilometers. Major rivers drain into Bay of Bengal. So your river mouth closing is a very important problem when you talk about sand movement. Then you have imbalance of sediments along the coast. We have certain locations you have more, certain locations you have less of quantity of sand. And where is the quantity of sand coming from? From inland as well as along the coast. So then what are all the type of problems you may have? Silting up of entrance channels, closing of river mouths, then problems related to aquaculture, but that is not so serious these days. But siltation of intake structures, that is very important for power plants. Then erosion of along the coast, that is the main topic of today's lecture. So average littoral drift along the east coast, although approximately it is said to be 1 million meter cube per year, and it is going to be seasonal. So this estimate, which is 1 million, has been established long back. But then later some of that is based on whatever information we had, visually observed data, etc. Based on that it has been established as 1 million. But then later there are reports which has come out which say that it is of the order of 0.6 to 0.8 million meter cube per year. All said and done, you have to you know that the movement of sand is along the north. So I have given in that clearly what are all the directions during which month, which season. So this is very important, and the assessment can be due to through calculations using formulas, and it is not so difficult to calculate the littoral drift direction and quantity. Both quantity, magnitude and direction is very important when you talk in terms of littoral drift. Let us move on to the most classical problem which has been entrenched in the coastal engineering practice. That is our Chennai harbour. So Chennai harbour is here. When you look at this problem as a whole, then what are all the positive and negative aspects? The positive aspect is the revenue from the port, employment, revenue, etc. So we know all the positive aspect we are not going to be bothered of, that's not going to be an issue at all. But the negative aspect is, one is erosion, which has taken away about 300 to 400 meters width of the beach over about 6 to 9 kilometers of the length of the shoreline. Then the other one is the silting up of the Coombe River. Coombe River runs all over the city. The moment you get down at the center station, you get the pungent smell that is coming from this river. So there has been a number of attempts to clean this river, but nothing has happened. So most of the types of solutions were giving a pair of training wall, but unfortunately not executed properly, although the design was okay, but it was not executed properly, and so it has not survived, it has not really worked well. So the next problem is this area. So we will move on to coastal erosion. So at that point of time, the local government department, what they did is, they had a water supply scheme which is called as a Veeranam water supply scheme, which unfortunately did not come through. So they wanted to use these pipes, and these pipes, how they can, so they closed one side, the bottom one, and then filled up with sand, and the top one also was plugged with concrete. So the entire thing was shifted to this place, and with stones here towards the sea, and these pipes were sunk here with tetrapods in between. So the section is as shown here, but this was a total failure. So total failure, as you can see in these photographs. Some of our earlier lectures, I think the students might have seen some of this, or in my NPTEL lecture also they would have seen this. So at that point of time, there was the Ennur satellite port which was coming up here. There are a lot of discussion about its location. I will not go into the details, and also the opening was this side. The sand is moving along the coast, and if the opening is like this, sand will automatically go and deposit there. So a lot of discussion had gone into that, and I don't want to go into that, but the problem pertaining to today's lecture is coastal erosion. When they have identified when this was identified, this two areas, this road becomes very important. Road connecting the two ports, that is the Chennai port is here and the Ennur port is here. So the distance is around 25 kilometers. We had to make sure that the highway is all right. How do you protect? At that time they came to IIT Madras, to our department, and then they consulted us, and then we had given a solution as we identified two stretches, stretch 1 and stretch 2, and we have given the design for. There are a lot of discussion. Initially we proposed only short groins, but the port people wanted longer groins because that will be easier to handle, that is what they said, and so finally it was decided that longer groins will be okay, and then we found that these two stretches were protected. One stretch is as shown here. So you see that the tips of the tips end earlier, that is, these are called as the transition groin field. That is, when the sand is moving along the coast, it is being trapped, the beach is advanced, the shoreline is advanced, but this area will be very pathetic because this is likely to have erosion taking place. So realizing that, we had provided a seawall to take care of it. And then once this was done, this was in the month of I think probably 2003 end or so, and the picture taken, construction was completed in around 2003, late 2003 or early 2004, and by August 2004 you look at the results we have got. But prior to that, this problem was in existence for about 5 decades. So many consultants had tried all over. They had people coming from different parts of the world, and then they were trying, and then so many solutions, but finally this groin field really came out. After we completed the project, we also started monitoring. So, how this, so the in between these two were calculated, and then you see that how much of sand has been, area of sand has been accumulated. When you look at it, so this comes to around 4,600. See, for example, up to August, mid of August, we had something like 8,800 square meter, which reduced to almost 50% of it. Why? Because of what? Tsunami 2004, that was in December. The sand that was formed in between the groins had been taken away. A lot of hue and cry that the sand has eroded. But then when we waited, because we knew that it is going to be deposited something like an offshore bar, and it really happened, although we have not measured the offshore bar. We waited for the monitoring, we continued the monitoring only to see that it has come back because of the formation of sandbar. So, most important is, so that has given us the National Design Award in 2008 that was given by the Ministry of Shipping, Government of India. Now, again one more example for the groin field. This is somewhere near Kanyakumari, just on the west coast, not on the east coast. On the west coast, the number of villages, about 6 or 7 villages, coastal villages, always experiencing erosion. With the experience gained in Chennai, Rayapuram area, this problem was referred to us, and then we took up this, and it was quite interesting. So, the idea was to have a proper design, but while executing you have to use the field conditions, and that is what we did. Some of these groins, original design was all straight, but some of the design based on the field conditions, we had changed the orientation of the groin field. As you can see here, one of the groin is going, and we found that there is a outcrop, and over it there is a church, and people used to go there and worship. So, what we did is we tried to see how it can facilitate the local public as well as protect the coast, and so we bent the groin and merged it with the the outcrop, and now it is serving very good, and these groins have served its best, were effective till date, and it is protecting all the villages, and the tsunami 2004 did not have much of effect along these villages. So, our experience in protecting these coasts gave us confidence. This enabled the government of states of Tamil Nadu and Kerala to entrust the responsibility of preparing the tsunami signature and then also mitigation plans. So, that was done by us. So, that is quite voluminous, both these reports. I will not go through. I think probably you can just check Google, if it is available you can download and have a look, because I cannot spare all those copies unless I get a clearance, but there are informations available in the internet. Now, while doing this kind of mitigation, signature studies, that is after the tsunami, soon after the tsunami, we went along, students like you, about 12 or 15 students, surveyed the entire, not 12, sorry, in this case for the tsunami signature study, there are only 2 students along with me. So, we surveyed the entire length of the coast, and then we found out what are all the things. So, we had given some specific locations with specific mitigation strategies. One, I cannot show all the, I cannot bring out all those information, but one information is that we looked at this Ratchagan Strait, which is at the tip of Cape Comorin or Kanyakumari. So, where we found the social aspects also is very important when you are planning for such a mitigation measure. So, we looked at these groins. That was done in mid 70s, which we understood that this is not serving any purpose, because for a simple reason that there is not much of movement of sand there. So only when there is a movement of sand, the groins will be effective. So this has not been effective at all. So, but then during the tsunami they had a lot of issues with the coast, because you had the water gushing in and there were some few deaths also. How do we answer this? Then we looked at the problem. We looked at the problem, then slightly adjoining the coast there is a small harbor, fishing harbor. These fellows, they don't, if they keep their boats there, then there is a big conflict. They don't allow these guys to keep their boats there. Big conflict. So we took that as a base, and what we did is only one extreme, this one we tried to extend up to about 400 meters. That gave us immediate results, and now you see that if you go to Kanyakumari, tip of India, then you will see this groin, very effective. It has become almost like a harbor now. So there is another aerial view of Uyali Kuppam. You can see this stretch of the coast was eroding. You look at the dwelling units there. We had protected this, and now this is the aerial view of and you see the number of boats that are berthed. Now we move on to one soft measure, that is bypassing of sand. This is one case study of Pondicherry. Pondicherry is somewhere here. So you have the Gandhi statue, if you have already seen there. Some of you might have seen this stretch. So this area was getting, there is an offshore, a breakwater here and here. So the ships come into the vessels come in this. So you have the harbor somewhere here, no problem. But then I am not going to touch on this aspect, but along the coast what happened, there is a deposition here, advancement of the shoreline, but then there is a severe erosion along this coast. So we looked at the past records. Central Power Water Power Research Station, CWPRS, had already given some kind of an idea that sand bypassing could work at this location. So they had a tunnel under this one, along these two, and they wanted to do this, but somehow it did not come through, and it was again referred to us, and then we took up this work. So these are the two breakwaters. These breakwaters were constructed by, we extended this breakwater so as to facilitate, because most of the waves are coming in this direction. So the maneuvering of vessels become very difficult. So if it is directly exposed to the waves, so we needed a protection measure, so we had the offshore breakwater. It is shore connected anyway, but that you see the advancement of the shoreline, because the drift, most of the drift is moving in this direction, prevented by this, but resulting in erosion along the southern coast. So what we did is we looked at all the past records, and then we found out this tunnel. So we did we decided to nourish the beach, and this is all open forest, people are not living there. So take the sand from here under the tunnel, nourish the beach. So this was the suggestion, and this was implemented in 2002, and we had got the results as you can see. Some of these results, yes, it is promising, but sustainability, that is the most important thing. You can have a solution, but then what does it, how long it can sustain? So it did not sustain. There are other issues which I don't want to go into the details, but one issue is, suppose in case the motor failed during a monsoon time, you can have power failure. At that time only the quantity of sand will be very high, and it will reach a magnitude that will be much higher than the capacity of the pump. So, all this are some of the issues, and we did some preliminary investigation after the beach nourishment, and we used the, what do you call that, we estimated the using the GIS software we tried to estimate how much is the extent of erosion was approximately 34 hectares, and the deposition or the accretion on the southern side is approximately 30 something. Okay. So, this gives us some information how the soft measure of sand bypassing, it works, but sustainability is the problem. We move on to slightly a different topic, application of geosynthetic material in the coastal environment. So, this is a topic which has been which has come recently, it is being discussed. Several works are in progress, but what are the geosynthetic applications? Instead of using stones, rocks, you have a tube about 20 meters or more. Fill up the tube with sand and plug it, and then this will remain as a protection measure. So, you do not need rocks. When you want to have rocks, so the depletion of rock, that is one major problem. Transportation of rock material is another drawback, and then handling it is also a drawback. But sustainability and also rehabilitation is easier, because if one stone goes, I can bring another stone and replace it. But if the case of a geotube, it is very easy to install and not much of damage done to the environment. So, it is said to be eco-friendly. Not only that, the geosynthetic material helps in growth of marine life. So, it can be used for you can have a pipeline resting on a material, I mean geosynthetic material, or it can be covered so that you do not have any when the ships are moving, the anchors etc. will not create any problem. All this all these things can be taken care, or coffer dams. Then you have the seawall protection, or you can have protecting the sand dunes, revetments etc. Then groins and jetties also can be used. Some locations you can also use a combination of geosynthetic material and the hard measures. So, narrow neck, this is artificial reef in Australia. This is one topic, one important case study which is always being discussed whenever someone talks about application of geosynthetics in marine environment. Narrow neck Australia is the most important thing, because they had a reef, as you can see here, and then they constructed, and this has given them beautiful, so you can see its result. The reef, as this was eroding, and now you see that it is the beach has formed. That is because of premature breaking of waves. See, if this is not, if this structure had not been there, the waves will be breaking somewhere here, because it has sufficient water depth for it to propagate. That is being deprived of by having this submerged reef, because of which the water depth is suddenly reduced and the waves start feeling its bottom and break, and the entire energy contained in the waves are lost, and then the sand which it is bringing is going to be deposited in between the shoreline and the structure, and that is how you have a beach, as can be seen here. This is one of the success story. Now, case study, because I had been involved in this project, I had the opportunity of seeing this project, that is in Yucatan province in Mexico, where the entire area was protected with an offshore geotube, submerged geotube. So, they used These are also some construction methods which during high tide how it looks, during low tide how it looks, etc. Some photographs which is shown here, and if you want to see, you can look at this link. I am sure that the lecture is going to come to you, and then you may have the opportunity. If you want to have details, you can look. So, for this a lot of information studies are needed to identify the location of the submerged geotube, so as to facilitate premature breaking for a wide range of wave periods and wave heights. So, geotubes parallel to the shoreline, as you can see here. So, this is a problem. See, this is a big problem. If you have not identified the site properly, the depth properly, it is not breaking premature. Instead, what is happening, it is coming and hitting the structure and reflecting. When it reflects, the wave characteristics are increasing, the flow field along the depth increases, so this cover takes place, and then the stability of the pipeline, stability of the geotube also becomes questionable. So, this is the appropriate way of mounting the geotube. Okay. So, that is from the international perspective. Then moving on to our work. So, we had been interested for carrying out one agency. I think this is from US, but they had approached the principal is in US, but their representatives, they wanted to install a kind of a seawall, which is called as a geosynthetic seawall, and that is how they termed this as a geosynthetic seawall. The design was given by them. It used a number of constituents. It has a number of products that was given to us, and the entire thing was modeled in the lab, because numerically modeling it's very difficult. So, we modeled the whole thing in the lab, and we did the test, and then after the test we installed the number of components which we have used are given here. So, you have all these things because again this is going to take a long time for me to explain the characteristics of all the components which have been used, and then we had those people who their representative also here, and we were also involved not only with the experimental work, we had given some suggestions based on which they had revised the design and then implemented, and when they were installing we were there to supervise also, and then before that we had done the experimental work also in our department, and then based on which to assess the stability was very important for it to be assessed. So, then we came out, and then it sustained. It is somewhere along the coast of Pallana in Kerala. I don't know how many of you are from Kerala. Pallana, I think, I don't know. So, it was installed there, and I believe this was done sometime in 2015, and I believe it is still in okay. So, this is the Pallana seawall, which is again a pilot plant, and it is fine. Now, we move on to the first experience. The first experience with geotube. This was done by our institute, by our department. So, this is the area which is called as Diga, or the area is called as Sankarpur in West Bengal, and this was getting eroded. So, what we did is this is the scenario status of the coast by mid of 2007. So, wherein you see that the erosion is taking place very severely, and then what they did, the local fellows were using what is called as ballas. Ballas are nothing but casuarina poles, driven on either side, and in between the casuarina poles they were putting small rocks, because they cannot afford to bring huge rocks. The unfortunate thing is, if they had done this somewhere here as a groin, probably it would have worked. But then this did not work, and in fact it paved way, and then you had erosion taking place here. So, when it was referred to us, when they asked us, so this is only 500 meters beach is available here. So, we do not want to use any natural rocks, we want to, because we would like to protect the beach and also avoid the inundation, that is flooding of the area. So, what we did is we used 3 geotubes filled with sand with this dark black color is there, that is what is called as a UV stabilizer, because this geosynthetic material, if it is exposed to ultraviolet rays, after a few years it becomes brittle. So, in order to protect that, we have what is called as UV stabilizer. And then what we did is we took a geotextile all the way from here, then this geotextile will go all the way here and then it will be wrapped here. So, that is what is the geotextile doing? It will allow the water, but it will retain the sand. So, no erosion will be taking place, but at the same time we have to have a strong toe, because to hold the geotubes. So, this was the original design. Unfortunately, what happened, this did not serve its purpose. Instead, there was a cover taking that took place here and the whole thing failed. So, we changed the design and we went in for an excavated toe. We excavated and then used what is called as geo containers. It is something like cement bags, but quite huge. And then we filled up all these things, and this area, because they wanted the beach, so we filled up with sand here. So, you have because no one will know what is happening here. So, this is the concept which came up, and then it was good, very good. It was serving its purpose, but unfortunately there are some guys who want to know what is there inside the geotube. That is curiosity, because we cannot blame them, you see. So, they wanted to check. So, these are all the construction point of construction sequence of this. So, all the entire construction sequence also was given by, and Professor Sanasraj and myself, we were involved in this project. It was a quite a prestigious project, and then we finished the project, and then you see what happened. The people, they came, they wanted to puncture to see what is there inside the tube. So, the sustainability is a big question mark in the case of geosynthetic products. So, this was actually before the construction and after the construction, when there was a storm attack. Now, advantages of advantages and disadvantages of geosynthetics are listed here. Easy to transport, steady installation, there is not much of a thing, only thing is you need some small machineries, but whereas but the disadvantages, performance must be all right, but ultraviolet rays is a big problem, and then this human intervention. So, all these things are given here. So, you can just have a read it yourself. So, what are the disadvantages, what are the advantages, then it is up to us to decide whether to apply, whether a certain locations, whether it is good. Still there are a lot of trials going on with the application of geosynthetic products. Now, finally, I will come up to what is called as the multifunctional aspects of the wave energy converters. Do not think that I have totally shifted to a different topic. I am going to merge this wave energy converter to coastal protection. How that is possible? Before that, we have to understand what is a wave energy converter. So, if you look at the energy, you have different types of energy. I am not going to go into all those details, but what I am going to talk about is the energy contained in ocean waves. So, distribution of energy contained in the ocean waves around the world is given here, and you can see somewhere here it is only 14 when compared to locations like this. They have 62 in the European countries, and even here along the US they have a lot more than what we have energy. So, if you want to extract energy from ocean waves, the amount of energy available along the Indian coast is not much. Off Bombay, yes, some amount of energy is available, but that is concentrated only during the June and July. And if you look at tidal energy, yes, that is available along Gujarat coast, but I am not talking about tidal energy, I am talking about wave energy. So what should we do? So MNRE, that is Minister of Renewable Energy, had assigned a project to us, and then we have evaluated the power potential, as you can see here, and this is what we have. So based on which we see that there are a number of locations which are green and blue, not much. So in order to tap that, we should do something. So what is how does it work? The principle of wave energy extraction is, when you have waves entering into a cliff, see, this is how it comes out. So you see that air coming out, that can drive a turbine. So now the same concept is installed now in the field. You have a bottom resting structure where you have what is called as a lip wall, and you have a hole here. This this movement of waves up and down within that chamber is going to result in air, which is oscillation of air in this chamber, and that oscillation of the air is going to drive the turbine. That is the concept. That is why it is called as oscillating water column. So there are major plants which have been operating. So the list is given here. You look at Vizhinjam, it was something on a width is given, the water depth was in 10 meters water depth, it was installed, and it is there in since 1996. It was proved that it works, but after that commissioning was a big problem, because the fluctuation of the power was also there. There are so many other problems, so it was given up, but it was proved that the wave energy caisson works. Now how do we combine this with coastal protection? This is the idea which we had been working. Now if you look at the offshore detached breakwater, this is one breakwater, this is another breakwater, and this has protected the coast. Now if we can install a wave energy caisson within this, then probably you can get the power as well as protect the coast. This is a very useful thing for maybe for islands. So this is the idea which was cropped here in our institute. So we did one of my student did his PhD here on this problem. He worked with me and Professor Sanasraj, and then we worked at so these are the detached breakwater with OWCs installed here. We monitored and then we got up some nice results, and it has been published, and some of these salient conclusions are given here. So now the cross section of the rubble moon breakwater is given here. The problem, okay, it was proved that OWC installed in a rubble moon breakwater works, and the detached breakwater is a well known aspect or well known mitigation measure for protecting the coast against erosion. So this is good, but then we did have some issues with rolling down of the stones. How do we control this? So then we went in for what we did, we changed the idea of rubble mound breakwater. Instead of that, have semicircular breakwater and install the OWC inside that, as you can see here. So we have one of our student is working right now for his PhD on this topic, and we have got some useful results, and we have integrated some of this. So we got some interesting results, and then we will just move on. So this is in the basin where we have tested for different wave characteristics, as you can see, and then we are coming out with some interesting results. and some of the papers have been published on this aspect. Another idea is to merge. This is not for coastal protection, this is for berthing structure, where you can install. So you have the vessel here, maybe 20 meters water depth or 10 meters water depth, and then you have a oscillating water column here. So you can extract the energy from the ocean waves, and this can be serving as a deck, maybe for loading and unloading cargo or passengers. This is another concept which has we had so you can see this animation here. So you can see the air coming out. So this is another area. So final is I think this is not the one. So strategies for extreme waves. The recent one is for the extreme flows. What we have done is see this restructured, recurved sea walls is one aspect, then buffer blocks and vegetation. I will just touch upon buffer blocks and vegetation where, so buffer blocks are used in dams. At the downstream of the dams you have buffer blocks which can reduce the when the water is flowing over the spillway with great velocity, the velocity has to be reduced, and that is achieved by having friction blocks. And this was the concept which we borrowed from conventional hydraulics for utilizing in the case of attenuating the flow during an extreme event. So and this is a project sponsored by German Science Foundation, and it is still in progress. It's almost coming to an end, the first phase. Probably we might get some funds for the second phase. So what we are trying to do is, we are already having 2 PhDs going on this problem. So the buffer blocks size is given here. So this is placed somewhere here so as to reduce the flow without any vegetation. We are not talking about any vegetation. Without this was actually one of the suggestions for Velangani, where when I did the tsunami mitigation plans, we wanted to have buffer blocks here with a sand dune, because people can come and sit and relax. So, and at the same time during an extreme event it can serve as attenuation or reduce serve as a mitigation measure in reducing the flow. So now moving on to vegetation again. So these are evidences that during the postmortem they found out that the vegetation has resulted in reducing the impact. So we looked at the Manning-Sen and the Darcy fixture factor. Now I think most of you are civil engineer, you must be knowing the importance of these 2 parameters. So we did the Manning-Sen are here. We looked at regular arrangement as well as the zigzag or the staggered arrangement, and we found that the staggered arrangement was found to be very good, and it also reduced the results are given here. We used what is called as a vegetal parameter, that is defined as the width of the green belt as well as the spacing between the plants and the diameter of the plant, and then you see that this is how the reduction is taking place when you have a flow in presence of the, and also this oscillation in the transfer direction also dissipates energy. The details are available in this paper that has been published. So we have almost come to an end, and that means it's around 5:30. I am sure that all of you are going to be tired. So what I have done is I have taken this time to discuss a few studies on the Indian coast, along the Indian, and on protection of the coast against erosion and also inundation due to coastal flooding, and then behavior of structures was highlighted, and then research work on flow, vegetation, interaction and buffer blocks were also discussed, and then efforts towards multifunctional structures and salient results were shared. Now, so this is what you can have. So this is disaster, this is rehabilitation. Chair, disaster, reconstruction. So you see the difference between rehabilitation and reconstruction. So reconstruction at certain locations are very important. finally, thanks to my students, colleagues and my co-authors. So these are all the books that we have published from our department. So you see 5 books published under the same and in fact there is a strong request to revise. So one of this book, that is Coastal Engineering and Theory and Practice, which we hopefully me and Sanatharaj will be able to do that in the coming year, coming months, not years. Okay. So thanks again. No, T type of grinds are nothing but after it's going to retain the, because when you have straight grinds, when there is cross shore, some of the sand which is accumulated, it's taken back. It may hopefully come back. So instead you don't want to lose that, so you have a T so that it is retained, number 1. Number 2, if you want to construct offshore detached breakwaters, then the construction has to come from the ocean side. It becomes all the more difficult. So T grinds facilitates shore based construction. It can be constructed from the shore and then you can have the T. So the T also can, T grinds also will be performing the function of offshore detached breakwater and grind field.